Welcome back to the last set of videos that I'm going to be making for truth tables. So in this video, what I'm going to be doing is looking at actual arguments and how we use truth tables to more or less evaluate, is an argument valid, is it invalid, how the heck do we tell? It's worth noting that, as with the past videos, we're going to be using the same basic 5 truth tables as a reference point for evaluation. So we get to go back and redo them again. The reason I'm being obnoxious about this is because when folks don't know how to do the basic truth tables, they don't know how to do any of the other truth tables. So let me quickly briefly sketch out all those truth tables again, and then I will work through some stuff that'll help you on homework and also tell you why you might be doing the wrong homework. It's 2.4.2, not 2.4.1. We'll get to there in a second. For now, truth tables. Let's quickly just do this one. So if you have a single letter, looks like this. A single letter or single proposition is either true or it's false. If you have more than one letter, and we're going to need a few of these, it looks like this. If you have an A and a B, you have 2 letters in our key area over here. This is the key area. You can also think of it as a value bank. It's a truth and false value bank. It's the value we're going to be pulling from to figure out what's going on when we get over into this side. Pick whatever concept works best for your understanding. Then we follow our pattern. 2 T's, 2 F's. Then alternate T's and F's. Then we bring them over. T, T, F, F, T, F, T, F. And what I'm going to do differently this time is I'm going to color the main operator a different color. I'm going to use red. When we get to the main operator, we want to figure out what operations we need to use to figure out what truth value that operator has. For an and statement, it's only true if both of them are true. Otherwise, it's false. Now let's do a few more. Same pattern for this one, 2 T's, 2 F's. Then we bring everything over. That's wrong. There we go. Now for the main operator, the wedge. It's true so long as at least one of the pieces is true. Otherwise, it's false. Then for the arrow, it's true so long as it's not T, arrow, F. Then for the last one, our lovely biconditional double arrow. Again, we're going to do the same thing that we've done. 2 T's, 2 F's, alternate T's and F's, bring everything over, and make sure you write down the right thing or not. If you don't, you will get it wrong on the exam or your homework. Then for the main operator for a biconditional, it's true so long as they match. So if 2 T's, it's true. If it's 2 F's, it's true. Otherwise, it's false. These are the basic truth tables. On an exam or anything else that you get, you're going to want to draw them, maybe even draw the negation one. Let's make the negation red, since that's the main operator. Flips the sign, just so you'll have something to go back to and take a look at if you get stuck. Now let's start looking at truth tables for arguments. In the last video, we looked at propositions. Propositions have this form for a truth table, where we have a truth table that looks like this. Then we have writing up here. We have some operator. Let's say that we have an and we have a main column. And we have like writing here, truth values up and down there. we look at this column and we ask, what is the combination of t's and what's the combination of f's? If it's all t's, it's a tautology. If it's all f's, it's inconsistent. And if it's t's and f's, it's contingent. That only works with propositional truth tables. But that's not the only type of truth table that we have in logic. We also have truth tables that are specifically for arguments. And when we think about arguments, arguments are either valid or invalid. Things are valid if the truth of the premises guarantees the conclusion. This is an important definition to know. It's an important definition because we could very well ask you something about it on the exam. Questions about validity and invalidity are fair game. Questions about validity and invalidity and what they mean for the arguments that we look at, for the proofs that we look at, for the 10 rules that we know. Those are all fair game in their conceptual questions. If you have questions about that, email me, but do know that that's something we could ask you about on the exam. Invalid, though, rather than the truth of the premises guaranteeing the truth of the conclusion, means that it's possible to have all true premises and a false conclusion. Let me give you a quick example of an invalid argument that's not in the form that we know it, or at least not strictly. So let's say that I have the following. I tell you that if something is we're just going to go back to our typical penguins. If something is a penguin, that is a very poorly drawn penguin, then it's a bird. Let's say implicitly that that's premise 1. Premise 2, somebody tells you that you have a bird. Conclusion, premise 3, or conclusion, line 3. Therefore, it's a penguin. And that's too bad even for me to like. Let me at least fix the head. There's a penguin. The question is this valid or invalid? The first premise is definitely true. If something is a penguin, then it is a bird. Let's say I give you a box. In the box, I tell you there is something in the box. You open up the box, and out of the box springs a duck. Or I guess it's a kiwi. Let's go with a kiwi. Or a dodo, something. So, the first premise is still true. If something were a penguin, then it would be a bird. If there were a penguin in the box, the penguin would definitely be a bird. The second premise is also true. The thing that is actually in the box is a bird. However, the third premise is false. We don't have a penguin in the box. As such, the truth of the premises doesn't guarantee the truth of the conclusion. Most of the arguments that we see in politics are actually pretty similar in form to this. Most of them are absolute garbage. Others are inductive arguments. There are good inductive arguments sometimes. But the form of the argument that we just looked at was this. A arrow B, B, therefore A. Bad. This is an invalid argument. So what does this mean for truth tables? When we think about truth tables, what they allow us to do is they allow us to look at the truth values that would follow if certain truth values were true of the actual variables. So if instead of having A's and B's, if I knew what the true value was of A, like if I knew it was a T or if it was an F, and I knew the true value for B, and if I knew it was a T and if I knew it was an F, then I get to figure out what the main operators are. A truth table is going to let us do that for an argument. And what we're going to be looking for is this type of thing right here. A case where all the premises are true, but the conclusion is false. And to see that, let's go ahead and start taking a look at a few examples. Examples are probably going to be the best way to learn these. Conceptually, they can be pretty hard to grasp what's going on. So let's use some examples and run through a few just to figure out what does it mean to have a truth table that tells us about validity? Like, how do you even figure that out? If this was a different logic class, I would tell you to do truth tables a different way that would make a little more sense possibly, but we had to stick with it the way that we learned it in this class. So let's draw a truth table. Let's use a different color though.